Hello, hello, hello. Welcome. Good afternoon. Thanks for joining us. Welcome. You have just started the TimberHP monthly Beyond Our Value webinar. Welcome. I'm Alexandra Hodges. I'm the sales and marketing coordinator at TimberHP. I'm joined today by two of our team members, Jason Todd, Director of Building Science, and Dan Edelman. He is the Business Development Manager for TimberHP. We're here today to talk about fire and acoustic assemblies. Hello, hello. I'm going to give just a minute for everybody to join us. While we're waiting, if you want to go ahead and throw in the chat who you are, where you're from, maybe what brings you here today, things that you're interested in, that would be a great way for us to kick off. A couple of housekeeping items today during the webinar. If something that is presented here prompts a question in your mind and you really want to get to the bottom of an answer, please throw all questions in the Q&A function down below. That's a lot easier for us to see and be able to answer either in writing or live. So the chat will do introductions, who you are, where you're from, and any type of questions that you have coming up today in the webinar. Go ahead and throw those in the Q&A. Dan Edelman will be fielding those questions primarily while Jason Todd gives our presentation today. So like I said, today's presentation is fire and acoustic assemblies with our product, wood fiber insulation in mind. We're going to look at an in-depth overview of code, kind of where we fit, and some of the testing that's taken place so far. Give it just a minute for anybody else rolling in. Today's presentation is not a for credit presentation. We've held a few of those in the past. I do want to let you know, though, that a similar presentation to this on fire and acoustic assemblies that does carry a CEU credit is forthcoming in 2024, so please keep that in mind. Those of you that have never watched one of our webinars before, we do host these every third Thursday of the month, right around 1 p.m. We'll be continuing the series in 2024. Next month in December, we're going to take a deep dive in the competitive advantage of wood fiber insulation. Looks like we've got some folks joining us. Hello, hello from Philadelphia. Looks like we've got some people from down south. Welcome. Going to go ahead and turn things over to Jason Todd, Director of Building Science. Jason, go for it.
Thanks very much, Alexandra. And again, thank you everyone for joining us today. Like Alexandra was saying, we are not presenting an AIA accredited session this time around, but expect to do something in the future. We do work with a few fire engineers who have been interested in supporting us in that endeavor. But I thought we'd get a little bit of information out into the market. We're hearing a lot about multifamily and residential and other building types out there. And where does this new product fit in all of it? We often talk about the pillars, if you will, the three-legged stool of concerns with wood fiber product, and that is fire, bugs, and water. And if you've been on other presentations in the past, you've heard some of this conversation before. We'll touch on the fire part today, and also a little bit about acoustic assemblies as well. Got two things up here. One is just our general intro to what TimberHP is and what we focus on, and then a little bit about what to expect in the session. We talk about HP times 3, healthy people, very important. Obviously, the folks inside of buildings, our homes, our offices, work environments, and also those that are doing the installation work, also people, by the way. Healthy planet, certainly of great interest these days. We talk about carbon, we talk about environmental stewardship, recyclability, all of that, very much big part of it. But all of that is led by performance, and we see it as high performance. And I think fire-rated assemblies, nothing really different there. I think we've got some great information for you today, and hope to add to that in the future. It's great to have Dan on the call as well. A lot of you folks have probably gotten a chance to meet Dan in this role or in a past. He's got a great deal of experience, and we'll be helping field some questions. Anything you want to add as far as an intro or introduce yourself to the group, Dan, before we get going?
Yeah, sure. So Dan Edelman, business development manager. I'm down in the Mid-Atlantic region, down in Pennsylvania, but covering a large area of the country. Yeah, my background is a lot of fire and acoustics. You know, I was concerned a little bit before too, about a couple years ago when I started seeing TimberHP kind of come to market, and I am very impressed with the fire performance of TimberHP products, or in particular the Timber Bat and the Timber Fill products. And you know, I'm looking at a lot of these assemblies that we're looking at, and they're very similar to other assemblies that are out there. You know, if it comes to, you know, acoustics and fire, we're actually a little bit better. And I think Jason's going to be sharing some things on why.
Yeah,
So,
absolutely. And I'm looking at through the chat, which Dan will keep eyes on. If there's
yeah.
a specific question that he's going to be able to answer just to address someone's concern, may or may not be beneficial to the group. I'm sure he'll respond, but we'll leave some time up at the end of the hour just to open it up to those questions, and we can kind of go back and forth in discussion. And I think you'll see that a lot of the questions that are being asked are around assemblies, and our ratings will hopefully be addressed in the coming slides. So real quick, we'll talk about the product line for those that have some familiarity or none. And then we'll dive into a little bit about the code. I'm not going to be able to address all of that at this time, but we'll get pretty far along, I think, in building types and material tests that are required of us and other insulation that's in the market. We'll talk a little bit about the resources that are available from us and from other support folks that we've engaged with in these early days of TimberHP, and also touch on some of the acoustic testing in the assemblies that we've done. So again, may have seen this slide in the past, but we are above grade solution. We've got a couple of different focus points: residential, obviously, multifamily, could be type 3, some heavy timber. We'll get into those building types. But great story around this product as an effective, high performing insulation product, but also touching on that the other 3 points that other 2 points that we've mentioned in the first slide about health, planet, and also for the people living in these buildings. Timber Fill in the market currently. We're selling through a number of different channels, focusing on here on our market in the Northeast, but we've got a real strong distribution network out there that keeps seeming to draw it further and further afield, which is great because there's interest. Seeing a lot of first timers out there and helping to support them with this new product. It's blown in very much like cellulose insulation. It is in fact cellulose insulation. Just looks a little funny. 3.8 per inch. I think the most important thing here is just that class A flame spread, and due to the boric acid.
And Jason, there was a quick question that just popped up from Ken in New Hampshire, and he's asking about how the product rollout is going and everything else. So do you want me to field that one?
Yeah, if you want to add a little bit, we'll talk about the 2 other products and where we're coming next. But yeah, sure.
Yeah, so Timber Fill is available now. Timber Bat will be available come January, and then the board will be in the spring and summer of next year.
Yes. So Timber Bat, we are making currently. Dan's taken some samples and chopped them up on social media. For those of you that are following Dan, always informative and very entertaining. Sometimes a bit of a daredevil risk taker in the front yard in the driveway, but exciting stuff. Nice thing about Timber Bat, we're using the same fiber stream. All of this is byproduct of other industries. We're not cutting down trees to make this. This is chips that used to go to paper mills that come from lumber manufacturing and other wood products here in Maine and neighboring states. We get a little bit better R value out of this bat because of the structure that we that we develop with some of the binders. We are refining that right now, and I believe we've sent stuff off to our third-party verifier. We expect to have that all wrapped up, running through a few holidays, might be speed bumps along the way, but in January, sort of middle of January, we should be seeing that out in the market. Again, Class A flame spread and smoke developed product. We'll talk a little bit about that in some coming slides. And this is the product that I think a lot of folks have been very interested in getting going in January. The board line is in place. We've been doing a lot of work behind the scenes, getting that put together, up and running. Slightly different process here. Won't get into too much of the details, but the R value ranges depending on the density of the material. That density of the material is relevant to the application. We can get some better R value from a lighter, less dense board, more strength out of the property with denser material in future roof applications, for example. And so range of R value, and currently a Class B flame spread. Keep that in mind as we move through the slides, as we touch on the fire classifications of the materials. So general statement about the building typology, and you can see it's a range from a non-combustible type 1 construction. And as we go lower down in those numbers to type 5, we get into the combustible range. And we've boxed out these lower 3 in particular, 3, 4, and 5 as a better fit. But in reality, we have a much broader application in building types. So hold on, I'm bringing out the boring stuff, but this is a little bit from the code. This is from the International Builders Code 2021. This is table 601, and I promise I won't show too much of this stuff, but we're looking at fire resistance rating based on building typology. And I'll show you some pictures because I know that's always helpful, although that doesn't always make it perfectly clear for me. In the end, type 1 non-combustible, type 2 also non-combustible, but not quite as protected. Type 3, we're considering ordinary construction, but still we're talking about commercial buildings there. And our focus, like I'd mentioned on the previous slide, has a lot to do with these lower 3 types. And I'll point out that in our ESR for timber fill, with the testing we've done, with the evaluation service that we had done in this ESR, we can see very clearly that in its uses that timber fill, and this will apply for bat as well once we get that all wrapped up, it can be used as a non-structural sound insulating material in buildings of any type of construction. That means type 1, that means type 2. Now, whether or not that got specified as often or if it really applies gets into the nuance of the code, which I won't cover here, but we are happy to dig in a little bit on specific projects. If you've got something that passed to Dan, for example, or to Scott Johnson, or anyone on our sales team, happy to work through some of the details, and some of the information you'll get in the presentation today will help as well. So we're going to focus on the back up. We're going to focus on the bearing walls, the primary structural frame itself. I've moved out of the view here, and we're looking at type 3, 4, and 5 exterior bearing walls, interior bearing walls, and non-bearing walls, all part of the structure. Note that for exterior or interior in any of these building types, we are talking no more than except for type 4A, which is the most fire resistant of that building type, mass timber, if you will. We're looking at a 2-hour at the most fire rated wall to the exterior. Now there's nuance with fire separation distance. The hourly rating of a non-bearing exterior partition wall may have to be increased from 0 to 1 or 2. But again, deeper code questions and conversation about what is being specified or could be specified with our products, we are happy to support. And I'll sort of leave it there, and we'll get into just an overview of the building types. If you don't know, if you're not familiar, the skyscraper, fire resistive, high rise, type 1, touched on that already. Type 2, non-combustible still, but often mid-rise. Masonry, steel construction, you're looking at a non-bearing exterior wall on the right-hand side. Insulation could be applied in some fashion to that in the cavity or as continuous exterior, with a few other caveats there that are best left to specific discussion. So again, our wheelhouse right here, we're seeing a lot more wood, which we appreciate. In construction, it's not exclusively wood. There could be some masonry involved in here. There could be some structural steel as well. But if you're looking at multifamily, some commercial and ordinary construction, that would be exterior walls. They need to be non-combustible or limited in their combustion. It doesn't say that expressly, but as you wind your way through the code and see some of the fine print in there, fire-resistant treated wood, either in framing or as a sheathing material, is allowable in that type 3 construction. And we can get pretty big on these things. Generally, they're 4, 5, or 6 stories high. There's a limit to height as we go down in our building typology as well. And if it is over 4 stories in any of the 1, 2, 3, or 4 types, we're going to trigger another test that I'll touch on briefly, and that's NFPA 285. That is a multi-story test. It's primarily concerned about the insulation and cladding on the exterior, weather-resistant barriers, the addition of panels with foam in them, foam itself. All of those things trigger that kind of test. That's the kind of testing that we will see coming into the new year as we get into the board product. And then also some assurances on our cavity fill as well. E84, the Steiner tunnel test. This is what determines our fire classification of building materials. For insulation in particular, we're looking to have a Class A product in the 1 through 4. Class B products are quite allowed in type 5 construction and residential construction. And it's really a good design in the end that makes those assemblies work. We have tested timber fill and achieved a Class A flame spread and smoke develop. 5 on the flame spread out of 25, very low. Smoke develop was very low, exceptionally low at 0. This is great news. This is largely due to the way that we're applying the borates, which is a mineral, a salt that gets added in a liquefied form and then sort of baked onto the fiber as it's moved to the drying process and into the bag. Same fiber stream for the bat. We are sending that material off right now to be tested in this same fashion. And just note that as we start up in the new year, in the first quarter, into the second quarter with the board product, we will see something that is not a Class A board. It's something in the future that certainly will happen. But I just want to show you this video. Some have probably seen this already, but we've got EPS foam here on the end. And then we'll go melt a few other foams, XPS foam. All of these are pretty much toxic soup by the time you light them on fire. As we get along to the foam boards, whether or not they are Class A rated foam boards, in fact, those that would be allowed in that multi-story testing, NFPA 285 for above 4 stories, there's a pretty rapid failure in those products compared to a fairly dense but a wood fiber insulation board. So you can see here it's starting to crack a little bit on the surface, glowing a little bit, but take that flame away, the building is still intact. The point of code around fire has to do with occupant safety issues, about escape, about firefighters and their ability to put out the fire, to access the fire, and to deal with the smoke and other toxins that get put into the air. So we're very confident that even as a Class B board, we can meet many of the requirements through testing. As we move through the year and we start refining our process and doing a little bit more innovation on that board, then I expect to see a Class A board and some significant fire testing to go along with it. So one of the more common tests when it comes to fire and fire ratings in particular has to do with full-scale assembly tests. And what you're looking at here is an infrared image of the furnace at ICC-NTA. You can see the orange heat from the chimney above and the wall that is put into that furnace that we get these hourly rating testing. So there it is in normal vision, and the guys are about ready to pull this apart. This was one of our 2-hour fire tests. You can see the timers run out at 2 hours and 9 seconds down there. And what we were testing was fire emanating from the exterior in particular, but it works both ways. It's a double-sided assembly. And we've done that testing on timber fill specifically. It relates to timber bat because we have very similar densities, and we've done some additional fire testing. We'll talk a little bit more about what we're going to do with that data. I really like to see the how-to in all of these things. I've always found it fascinating to know how this all works. And so it was great experience for me to observe the testing. And the additional judgments that will come from it have to do with this testing. We started with something that was trying to maximize the potential load that that wall could carry. So it could be an exterior wall in some construction types. It could be non-structural. It could be a partition wall in the middle that's just dealing with acoustics, dealing with fire and acoustics in the hallway, for example, or between rooms in a particular building. And after burning the assembly for an hour or 2 hours or whatever that rating is that we are chasing, there's one more part of the test, and that's the hose stream at the end. And the idea here is that you need to put the fire out. We've hopefully gotten the occupants out within the 2 hours that that thing has been burning. But as we hose this building down, what happens? Will it fall apart? Will it collapse, cause structural failure, and put other people at risk? So it is very reassuring to me that we have done this testing, that we can back this up with the data, and with our fire engineers we've been working with, we'll be expanding on that a little bit more. And again, and this is the end result. That's some of the sheetrock, a little bit of the insulation at the end of the test. It's a up close of the furnace, and I'll get into some of the details that came out of that. Worst case. So what is the worst case? It's a thin wall. It's one that could have issues structurally. So wider stud spacing, and the minimum amount of gypsum on the exterior. So one layer of 5/8 on both sides for a 1 hour wall, 2 layers both sides for 2 hour firewall. And so that's fire from both sides, depending on a few things, including that fire separation distance that I mentioned earlier in the code, but didn't get too deep into. The closer you are to other buildings, the more of a concern it is. Fire from the other side, from another building. As you get further and farther afield, 30 feet out, there's nothing around you. Our concern may not be so much from the exterior, but we still could have fires from the interior. So these walls are double-sided. Widest framing possible in each instance. And in that, an engineer, a fire engineer, can therefore write up a judgment that adds more options along the way. And that's exactly where we are now. I don't have all of the listings done at this point, but they are in the works. And so you can see the results from the testing and gave us a 100% design load. In this case, it's a 2x4 wood stud, 24 on center. And in that framing, we can have option to increase the depth of the cavity. It could be a 2x6, for example. It could be 16 on center or 19.2 or whatever smaller framing that's going to give it more structural strength. Exterior sheathing, we can make this an exterior wall with wood structural panel, with FRT studs or sheathing, or changing the gypsum out, and there are some other options, including cladding types. The goal is trying to figure out the best way to provide as much information as possible to those that want to specify these assemblies. So you draw up a wall, you know what it needs to look like. You might pick from a database. A lot of folks look at UL. They've got a great searchable database. It's very specific to the assembly, UL 305, 309. Not all of those are coming from UL. A lot of them came from the Gypsum Association and the testing that's done, and you can find some great information in that fire resistance and sound control manual. USG, a manufacturer of gypsum, has a number of wall assemblies as well, and you can tell by the code or the listing name what they are exactly. So being the new insulation kid on the block, we might not be in every single specification to start, but also being something new and of interest. A lot of people are asking how we get into the those assemblies, and we've chosen one path, and that is with ICC and the evaluation service and the listing service in particular. What I will be able to show you very soon is our listing report, and that will be similar to this ESR evaluation report, but it will also have home on their listing report directory. And you can see, you can break it down by division. You could get down into insulation in particular and see some of the other products that they have listed. And in that listing, there will be 3 designs. And those designs, as you saw on the previous screen, with some of the additional options, will have a more robust, more available alterations within the listing. So we can even line that up to a UL listing and show that to a specifier or to an engineer, the AHJ, the authority having judgment, the code official. And they should be able to look at that in our listing and say, okay, these are 1 for 1, the same thing. That's a great substitution, no problems. If it gets trickier, if there's more nuance to it, then certainly reach out to us. We do have a few folks that are able to write judgments as needed. Back to that fire resistance and sound design manual. The Gypsum Association, it's quite a big book, couple of different references out there similar to this. And this, I think, gives you a bunch of those assemblies, very much like the UL listing does. But if you have a design that's out there, it's a standard UL design or a GA design, know that for walls in particular, it's really not too heavy of a lift to substitute with another product. We've got Class A rated materials, cellulose-based materials. And in this manual, and that's backed up by the Woodworks Wood Product Council, support this as well. You are allowed to add cellulose fiber insulation, thickness not exceeding that of the cavity depth, and that's in an existing standard. So there's one out there and it says the cavity's empty, or it might have a particular batt insulation, but not ours yet. We can work with you and get that clarified That works for cavity fill in any building type. And UL has some language similar. They're not quite as inclusive in materials, but for now, in the code cycles we're in, this is an acceptable substitution methodology that can help. So I touched a little bit on 285 testing. This is the testing at the testing facility down at NTA. We'll likely do some more work in the very near future as we get into board. And I'll just say that, you know, the requirement for this is above 4 stories or 40 feet in that first 1 through 4 construction types. So even in the non-combustibles, there are some applications where you might put combustible material on the exterior. And a good example of that are weather-resistant barriers, a metal-clad panel that has a foam core, other siding options that could go to the exterior, wood fiber insulation board, foam board. We're not covered in plastics, we're covered in wood in the code, but still we will need to test, even with that class B board possibly, over 40 feet walls need to be tested to this standard. And I feel very confident after lots of discussions and strategy with the engineer we're working with in particular that we'll get there with that board. And again, looking at adding the additional fire classification in the future. So more to come on that in the coming year. I'm going to hop over to acoustics as we head towards the home stretch here. And I love this picture because I got to visit this room. They didn't have the box anymore and they didn't put me in it, thank goodness. But this is part of the testing facility at Riverbank Labs outside of Chicago. Eric had presented a little bit on acoustics in the past. I won't get into the deep dive on that, but just express a little bit what we did, why, and what we have for resources now. The guy is in the box, by the way, because daily he's going to change clothes, but they would not influence the testing. This is for a noise reduction coefficient of a product, and I guess they used a pipe organ. But the facility is modernized to some degree, but not entirely. It's still in an old, beautiful building and a lot of history, a lot of talk about cryptology in the early days. It was a birthplace of the NSA and code breakers. Very instrumental folks came out of this facility in the early days, but they had a little bit of a magical sense of science, the gentleman that started this facility. But luckily he paid scientists to come work for him and try and solve all the things that he thought were important things. And when they finally convinced him that all of that stuff might not really be legitimate at all, but they had valid projects on their own, and some of them were around acoustics, it blossomed into one of the premier and probably earliest sound testing laboratories. You can see in the photo on the left-hand side, we're in a sound room, and that big black box is making a lot of noise when the test is up and running. We've built a wall into an area similar to the furnace, if you will, of the fire testing. We've got an enclosed, protected area, and we're subjecting it to, in this case, sound. As I run the video on the right-hand side, if anybody's sleeping, this might wake you up, but in that room, loud noise. And then on the other side of the wall from the room on the left, we've got the back side of the assembly, and that's the result. And that's what's being recorded from one side to the other, which gives you the STC rating, the sound transmission coefficient. And that number is the results that we have here. We've modified this sheet a little bit. Some assemblies are just not very commonly listed. mostly we're looking at anything over an STC of 50. You can see from the list in a 2x or similar metal construction, we're hitting some numbers above an STC of 50, and certainly adding some resilient channel in that helps. We will do some additional testing as we get more product out there, as we get more of the board into the market in particular, and look at some floor testing as well. If there are assemblies in particular or questions in particular around sound, in addition to fire, please reach out to those that are either selling the product, your local distributor, our info at our inside sales folks, Dan and others on the sales team. We have this data. We're looking for what next. So if you have suggestions, recommendations, we're all ears by all means.
And Jason, I was going to add too on this is really it's just the density and mass of the material. We're at a 3-pound or ish density for fill and bat. So that's really going to just help with the overall sound attenuation of that wall system. So when you look at the densities of other insulations out there, they range anywhere from as low as 0.4 all the way up to like 2.2. So we're going to be superior on how much density and mass. I'd say, and Jason, I'm sure you could agree that a 4-inch concrete wall is probably better, but not many people are going to be building 4-inch concrete walls in their homes. So kind of the next best thing is a 3-pound density bat or fill product.
Yeah, and it's a great point. In residential construction, we know we want sound attenuation, but we might not need a specific listing or a number attributed to it. Density matters, absolutely. So if you have a bat product out there, pink fluffy stuff, for example, that's much lighter. There is a tipping point. There's a tipping point depending on the frequencies, and we can get into a little bit about that with the curve here on the right-hand side. And if you go super dense in a material, and if you get above 5 pounds, it actually might start resonating some of those frequencies, and you might hear lower voices, or you might hear higher frequency sounds. Not a floor tapping test where you get that impact resistance, and that's something that I'm interested in seeing as how the board plays out. But absolutely, big mass walls tend to help in lots of ways, but they also transmit in certain ways too. So the concrete wall Dan was referencing might not work as well as a lower density in some parts of the frequencies. Because of that, might work much better in others. So just some of the transmission loss on the right hand side and the different frequencies, the curve as it's supposed to lay out, or the average, I guess, of that curve and what actually was registered, and just to compare to another fiber material. In this case, it's AFB. We've got an STC of 50 with that same listed assembly, and we were significantly more on that case, which is kind of a surprise to me, but there is some variation in those test reports. Rockwool is same in a wood framed assembly. In this particular assembly, I think it's worth noting that the thinner profile 2x4 wall can also achieve a STC of 50 in this case, which is a little bit higher in Rockwool. You're starting to split hairs when you get into 1 or 2 STC points, if you will. But in the end, it's a great product for sound reduction, and whether or not that's a rated assembly or just adding some of that mass to slow things down a little bit in the cavity. Some of the resources you can find on our website, the technical library, under the resources tab. We also have some videos up there. And this will grow as we add more materials, more references. We've been dealing a lot with just machines and settings. That's something that should go up here as well soon. And what I am very excited about and have been working on for too long now, with some help from heavy lift help from Dr. Joe Stiebrick from Building Science Corp is our builder's guide, and we are in the home stretch. Some folks have seen some pre-release images and sections. These details, I think, not to be expressly related to fire and sound, although there's some discussion in there in this, will, I think, help those that are specifying, trying to figure out best practices. And this is going to be a living document. This is going to be something that grows as we also grow and expand our product offerings. This is specific to all climate zones. We are looking at 1 through 8, and it may not be all of the assemblies you could dream of, but it sure has a lot of them and some good sound information. So expect to see that coming before the end of the year, and that should pop up on that resources tab as well. I have a little bit about, we've got one more coming up, competitive advantage in December. We'll talk a little bit more about some of the good metrics of wood fiber insulation. We're going to be mixing it up in the new year. I think you'll see more of Dan on some of those future sessions, maybe a little bit different presentation, but like Alexandra had mentioned earlier on at the beginning of this presentation, we will also follow up with some more deeper dive, in-depth AIA supported Beyond Our Value education series. Appreciate that when manufacturers can share some of the knowledge, the experts internally or externally, and we wish to do the same. I think it's great to learn. Those are not so much of a product pitch as you might expect, being credit oriented. And again, happy to hear more about what you folks out there would like to see more of. I think we're going to start talking to more builders in the future. But we also have great resources and great partners in the industry. And I think that you'll see some additional sessions coming up.
Speaking of what the folks want to see, Jason, we just had a question come across the Q&A saying, can you please show the picture of the man in the box again? So are you able to pull that slide back up?
I think, hold on, you might get dizzy.
And then while Jason is doing that, we do have another question that came through the Q&A, and I'm hoping that Dan can give a little insight here. The question is, can the wood fiber board act as roof sheathing and thermal break also?
So definitely yes on the thermal break. That's what it's pretty much made for now. In terms of structural capacity and walking on the board, I would still like to see roof sheathing, but it can be done. But again, you want to basically have an engineer look at the details, make sure your shear's right, your what is it, roof blow off conditions, wind conditions, like there's a lot of other things that kind of, so I'd say it depends, but it is possible.
I would say that some of that will be addressed in the guide. Another resource out there are some of the European manufacturers' designs and drawings, and it's possible to do a board on the wall or the roof without a structural sheathing, as long as there's some other structural accommodation. We've got some work ahead of us when it comes to roofs. Again, some of that will be in the guide, and then I think we'll have some breakout information going in to more depth, because you're absolutely right. There's some concerns when you start walking on something, but again, higher density board too. We may end up with 2 product lines, one more for that higher density application and one for optimizing our value.
Yeah, you put the lightest guy on the roof when you're doing that project,
and the smallest guy in the attic to get through the hatch.
And there's a follow-up question around the assembly saying, can you nail the asphalt shingles directly onto the wood fiber?
I would say that the guide will be a good reference point for you there, but generally we are going to look for a little bit of gap drying potential. We are still a wood fiber product. It would not likely be either an over roof application, so you've got sheathing with a little bit of gap, so you're essentially venting that space, or something that you would have to, as at least have a proper nail base for those shingles. So I would say probably not. It'd have to be a secondary deck above or a deck above as a nail base, and that deck is then secured to the frame.
So the other part of that, the building science side, you're putting an asphaltic shingle on top of a vapor open assembly, essentially, because if you don't have sheathing, if you don't have anything else, any vapor barriers underneath that, that vapor could migrate and actually get stopped by that asphalt shingle. So you would really need a rain screen, a roof rain screen, a roof vent. On top of that, with an additional layer of sheathing, and then that sheathing layer is going to be your nailing base.
Yeah. I don't think I've got, again, the guide is something that's worth a full presentation, and I would expect that we'll end up with that alone. But this is climate zones 1 through 3. We've got tile, but that tile is a vented space. We've got roof sheathing on there. We've got a vapor retarder, in this case paper, asphalt, tar paper, if you will. But most often you're going to have a hard stop, as Dan was talking about, for that moisture migration and airflow, whatever that method of the moisture moving around is. Hard stop between inside and outside, and the board could be above that with some accommodations for its own drying and also for just the protection of the roof assembly itself.
And one other question that I wanted to answer live too, or I guess more of a comment, but STC numbers for CLT construction, the comment was basically they would be expected to be higher than a conventional 2x4 wall. And I would definitely agree. I don't know how much higher. And, if the testing, I'm sure we could do testing.
Yeah, I don't know that I've seen much testing on or any testing on a slab CLT. It's going to depend on the thickness. Again, impact versus STC is going to be significant. What you're applying to that and how that's being applied will matter. We do have a few details that I still need to do some work on in this builder's guide around CLT, but not too many. But it could be continuous exterior with a thick mat board, and then that would be what we would need to test. And honestly, that's more of a OITC and outside to inside test, which is slightly different, but those numbers have been done as well on all of those assemblies.
Yeah, and a little brief history too, Jason. I'm sure you're aware of this, but STC was actually developed back in 1969. They're only measuring from 100 hertz or 125 hertz up to 4,000 hertz. So there's a lot of frequencies that doesn't even really pertain to the STC testing. And in the lower frequencies and the higher frequencies, that's where a denser product actually really does shine. When you start looking at other STC ratings for different assemblies, there's even fiberglass assemblies that show a 44 STC rating for a 2x4 wall. So that being said, you really need to look at more than just that small broadband of hertz ratings.
Right. Yeah, and it's always a little confounding that the STC information that I found in Europe didn't translate easily because they choose different frequencies.
Mm-hmm. Yeah.
We've got a little bit, looks like it's popped up in the chat about installs. Ken had asked about timber fill being blown wet. Spray applied application. For those that don't know, I believe what's being referenced here is damp spray, and in cellulose in particular, you can apply that into the cavity with a little bit of moisture as well. So it's blown the same way, but from a distance, and kind of mats as it's moved back and forth as you spray into the cavity. Rock wool, a blown rock wool product has been done this way with a binder. You add a little bit of glue as well. Spraying loose rock wool is not as common for a lot of folks. But I believe even with fiberglass it could be done that way. But cellulose, traditional newspaper cellulose has sort of dominated that market, and a little bit specialty equipment, very fast production rate. The answer after all of that explanation is yes, I think it can be spray applied. We are just starting to experiment a little bit, though. One of the machine manufacturers that we've been working with had done a job recently, a little bit to work on there for the future. But for those folks in particularly drier climates and warmer climates, because it limits drying is limited when it freezes, for example, or if it's super humid out. So there's some environmental conditions to be aware of with spray applied, but I think it's a possibility, and we will be exploring that further.
And I did throw in the chat, but I'm noticing that the hyperlink did not transfer when I copy and pasted. We did just release a Timberfill install guide. That is our one product that is available on the market right now currently, depending on where you are around the country. And so that guide, you can either, oh, thank you for whoever just turned that into a clickable link. Appreciate that. I was also going to direct you. It is contained in the technical library page of our website, which is linked slightly above, as well as the acoustic sheet that Jason had shown a while ago, and a number of other great resources. But if you haven't checked out that page on our website, it is worth a look. If you have some nitty-gritty questions, there's a lot of good information there. And we're always available for follow-up questions after the fact as well.
Great. We've got a few minutes left. If there are any additional questions, if not, I will say thank you very much for joining us this month, and look forward to seeing some of you and some new folks in the next session in December. And very excited to see what will come of Beyond Our Value continuing education once Dan Edelman gets his hands on it. I have a feeling it's going to be a fun ride. A little bit of everything, you know, gonna be good stuff.
We're gonna have
and
more.
I will say, I'll give both of you a good plug. Both Jason and Dan are very active on social media, and worth a look if that's your thing. If you're an Instagram person, or you just like to do a little bit of scrolling in the evenings, both of their pages are full of both technical information and also just something to give you a bit of a smile at the end of your day. So go ahead and check them out. Jason Todd, TimberHP, as well as Dan Edelman, TimberHP on Instagram.
Good social on many levels with our company. We've got a lot of good folks behind the scenes working hard. There's more out there for sure. But let us know if you have any additional questions, any follow-up, and we'll see you next time.
All right. Thank you guys. Good seeing you.
Thanks, everyone. See you next month. Bye-bye.
Take care.
Take care all.